Rahman Rahim. Now we're going to start our revision of dynamics. We'll start with rectilinear motion of any body. Rectilinear motion of a body means this body is moving in a straight line. Okay, we have two topics to deal with in this unit. We have differentiation of vector function and integration of vector function. We'll start discussing differentiation of vector function. Differentiation of vector function. First, we have four vectors relating to the motion of the body in a straight line. We have position vector, okay, and denoted by R, and we have displacement vector as S or X, and we have velocity, of course, velocity vector V, and acceleration vector A. Okay, first, the displacement S or X equals R minus R naught, equal displacement of the body equals the position vector after time n minus position vector at the start of the motion of this body. Okay, S equals R if the body is starting from a certain point or from the origin point, R naught equals 0. Okay, this is the displacement of the body. Here we can find also V equals the first derivative d of displacement of this body with respect to time, okay, or this is equal dx by dt. Okay, we can also express this as if we have this curve relating to its displacement or x with t of the motion of any body. Then the slope, for example, like this, the slope of this slope of the tangent of the curve, okay, st, okay, is representing the velocity of the body motion, of course, at any time t. Okay, then here this is representing the velocity of this body at time, for example, t1. Okay, then we can find also a vector, acceleration vector, equals dv dt, first derivative of the velocity vector with respect to time, or of course second derivative of the displacement with respect to time t. Also we can express a as v dv dx if we have a relation between the velocity of the body with respect to the displacement. We can find a as v times dv dx, and also we can use the algebraic measures. Then we have acceleration equals v dv dx. Now we'll move to the integration of vector function. Okay, here we have the velocity v equals integral of a d time. Okay, as we know, the definite integral, for example, from a to b, f dash of x dx, this is equals f of b minus f of a. Okay, this is called the definite integral. Here in definite integral we have the velocity of the motion of any body equals integral the acceleration dt. Okay, if we have limits, then v minus v naught, v is the velocity of this body after time n, minus the starting velocity at time 0. This is equals the integral from 0 to time t, okay, for a dt. Okay, this is indefinite integral and this is definite integral if we have two limits of the motion at times. Okay, in case of motion under constant acceleration, we can apply directly this relation v equals v naught plus at. Okay, as v equals the velocity of the time of the body after time n, and this is starting velocity, and its acceleration and time n. Okay, also we can find v as area under the curve of A and time. If we have a relation between A and time, then the area under this curve representing area equals velocity during of the body during the time interval, for example T1 and T2. Okay, if we assume this moment is T1 and this is T2, then the area under this curve representing the velocity of the body during this interval. Okay, also we can find acceleration, okay, or displacement first. Displacement x or s by here we have x or s equals indefinite integral of the velocity of this body at any time related to dt. Then we have x equals integral v dt. If we have starting position, then x minus x naught equals definite integral from 0 to time t v dt. Okay, also we can find this if we have a relation, this relation between velocity and times. Okay, then the curve in this the area under the curve between, for example, T1 and T2, representing here this area, equals the displacement of the body during the time interval T1 and T2. Okay, in case of motion of any body with constant acceleration, we can to find the displacement of this body after time t, we can apply this motion relation or motion law. X equals x naught, this position of the body at time t equals 0, plus v naught t, okay, plus half a t square. Okay, now for the velocity, we can find velocity as integral of v dv equals integral of a dx. Okay, as we have a equals v dv dx, then we can find this relation, integral v dv equals integral a dx. Then if we have limits here, limits, for example v naught and v1, and we have here x naught and x, then we'll find half x v squared minus v naught squared, okay, equals integral from x 0 to x a dx. Okay, also in case of a equals constant, then we can apply v squared equals v naught squared plus 2 ax or s. Okay, also if we have the relation between acceleration and x, okay, then the area under the curve between x1 and x2, this area represents area equals half v squared minus v2 squared minus v1 squared. Okay, this is the area under the curve ax between x1 and x2. We have to differentiate between two terms. We have v average equals distance over time. Okay, while we have v vector, v average vector, this is equals displacement s vector over time. Okay, we have to differentiate between these two terms. V average equals the total distance, okay, over the time. The total distance, of course, we'll assume it as positive. Okay, if it's in negative direction of the regular direction of this motion, then we'll convert it to positive and add all this distance together and divide it by the total time to find v average, the average velocity of this body. Okay, but we have here v vector average equal the displacement of this body over time. Okay, here the displacement may be positive or negative according to the direction of motion. Now we are going to explain the curves, okay, of the function, vector function, okay, and time, okay, relating to the motion, rectilinear motion of any body. First, we have the vector, we have the curve, okay, representing the relation between position r or s or x, okay, and the time t. Okay, if we have here a relation between x or s with time t, okay, then we can find from this curve we can find the velocity of the body, as the velocity of the body equals the slope of the tangent to the curve at any point, at any time, for example t. Okay, then we have here this curve, and the slope of this curve at any time t, for example t1, representing the velocity of the body at this moment. Okay, if the slope is positive, then velocity is positive, and of course if slope is negative, then velocity is negative. Okay, as we know, the slope of this the slope of tangent of this curve at any point, representing the tangent of the angle made by this tangent to the curve at any point with positive direction of this axis t or x axis. Okay, here then the slope equals tan theta in this case. Okay, of course if this angle is acute, then the slope is positive. Okay, in case of acute angle, in case of obtuse angle, then the slope is negative. Okay, if we deduce that the velocity is positive here, as the slope of the tangent of this curve at any point is positive, okay, then this means the body is moving forward. Okay, move it forward. Okay, and also if the velocity is negative, then the body is moving in backward direction. Okay, this is first curve. Secondly, if we have a curve representing the relation between displacement and time, okay, from this curve we can find the acceleration of the motion of this body. Okay, as we have here this kind of curves or this type. Okay, here in this type the acceleration is negative. We have here negative a, here we have positive a. This curve is called downward convex. Okay, convex downward. Okay, in this case acceleration is positive, and here is upwards convex or convex upward. Okay, then the acceleration in this case is negative. Okay, also we can find the type of motion of any point of any body. Type of motion we can explain it as follows. Okay, type of motion means is motion is accelerating, okay, or decelerating. Okay, and also it's in forward or backward direction. Okay, we have to identify both of these items. Okay, first, as we said before during the explanation of the velocity, if the velocity of if the velocity is positive, okay, then the motion is forward. Okay, if the velocity is negative, then the motion is backward. direction, in backward direction. Okay, this is first item. Okay, if when we said the acceleration, the motion is accelerating or the body is decelerating, here we have to say that we have to check the product of VA. Okay, if VA is greater than 0, positive quantity, then the motion is accelerating, okay. If V cross A is less than 0, then this quantity is negative, then the motion of the body is decelerating. Okay, then we have to find the at any moment or any time interval, we have to find V, the velocity and the acceleration of the motion of this body, and multiply V times A and check the sign of the outcome. If this quantity VA is greater than 0 or positive, then the motion is accelerating. Okay, and if VA is negative, then the motion is decelerating. And to identify the motion is forward or backward, we have to identify or to find or check the velocity sign. Okay, if the velocity is positive, then the motion is forward or the body is moving in forward direction. If the velocity is negative, then the body is moving in backward direction. Finally, we are going to explain the curve representing the relation between the velocity of the body at any moment with time. Okay, here we can find the sign of the velocity. If the velocity of this or the curve of representing the velocity of this body, okay, is above x-axis or time axis, then here velocity is positive. Okay, if the curve is below this horizontal axis, then here velocity is negative. Okay. Also, if we have, for example, this curve, okay, in V time, then the slope of the curve of the tangent okay, of the curve VT at any time or moment, okay, representing the acceleration of the motion of this body. Okay, the motion of the body. Okay, then if we find here, for example, this tangent, okay, then the tangent of this the slope of the tangent of this curve at this moment representing the acceleration of the body motion at this point. And of course, if the slope is negative, then the acceleration is negative, and vice versa. If the slope of this tangent is positive or making an acute angle with this horizontal axis, then the acceleration is positive. Here we can collect all types of curves in this topic. Okay, for differentiation of vector function, we have these types of curves. Okay, if we have a curve representing s or x displacement with time, okay, then the slope of this curve at any point equal the slope of the tangent of the curve at any time t, representing the velocity of the body at this time. Okay, if we have this type of curve representing displacement with time, then to find the acceleration from this type of curve, we have this downward convex curve. Then here we have acceleration is positive. If the curve is upward convex, then the acceleration is negative. Okay, and as we said, we have to check V times A, velocity times acceleration within any time interval. If this product is greater than 0, then the motion is accelerating or the body is moving in accelerating motion. If VA is less than 0, then the motion is decelerating. Okay, and also we have this curve representing the relation between the velocity of the body with time. If the curve is above this horizontal axis, time axis or x axis, then the velocity is positive. Okay, and if the curve is below this horizontal axis, the velocity is negative. Okay, we can also find the acceleration from this curve by finding the slope of the tangent of the curve at any point. This is representing the acceleration of the motion of this body at this moment. Okay, and of course if the slope is positive, then the acceleration is positive and vice versa. Okay, and also we can collect all types of curves for integration of the vector function. We have these three curves. The first one representing the relation between acceleration and time, okay, of the motion of any body. Then the area under the curve between t1 and t2 representing the velocity of this body during this average velocity, or the velocity of this body during this time interval. Okay, if we have the curve representing the relation between v and time, we can find displacement s or x of this body during t1 and t2 by finding the area of the curves below these two times or within this time interval. Okay, also if we have a curve representing the relation between acceleration and displacement, then the area under this curve between x1 and x2 equals half v2 squared minus v1 squared, the square of the velocity at x2 and the square of the velocity of the body at x1. Okay, then finally, when we are dealing with these different types of curves, we have first to identify the type of the curve representing the relation between which two variables, okay, this one and this one. And second, we have to decide which data or variable we can deduce from finding the slope of the tangent or the direction of convection here. Okay, convexity here if it's downwards or upwards. Okay, and we can find also the sign of the velocity if the sign is above x-axis or below x-axis. This is for differentiation. For integration, we have also identify the variables represented by this curve. Okay, and identify which variable we can deduce or find by integrating or finding the area under the curve in each type of these curves.